Hello everyone, I would like to welcome you today to our little meeting here on the couch. I want to talk with you today about the CarboSeq project within the EJP Soil framework. My name is Felix Seidel, I'm the coordinator, and next to me is Axel Don, the lead of the CarboSeq project. Today I would like to talk with you, Axel, about soils and CarboSeq. And I dive right in. Aren't soils great? Because they seem to be the solution to combating climate change. For example, if we would just, on all soils of the world, increase the carbon content of the soils by 4 per mil, we could directly mitigate all the CO2 emissions that we have in 1 year.
For sure, and that's where the 4 per mil comes from. The name 4 per mil comes from this increase in soil carbon, and this initiative was launched already 6 years ago in 2015 at the famous COP21 in Paris. But is it really possible to sequester so much carbon at a global scale?
It has been shown on the example of Germany that with the introduction of cover crops, you could increase for German agricultural soils the total organic carbon content in the top soil by 5 per mil, which is a whole per mil more than we need.
Yes, you're right. But croplands, they cover only 9% of the global surface. And you can only grow cover crops on croplands. And moreover, you need croplands where you have cover crops already growing, so not part of the crop rotation. So that really decreases the area where you could sequester carbon with cover crops.
Yeah, but also there are, of course, other management options we could choose for other types of agricultural land, because the key element really is just to increase biomass, isn't it?
You're right. The biomass, you mean the litter, the leaf litter, the root exodus, all the crop residuals. That's important.
Isn't it then a possibility, for example, to increase this biomass? For example, we could use organic amendments. Is that a problem, or is it easy to just increase biomass all over the place? What do you think?
Also, the organic amendments are derived from biomass somehow, and this is really the problem. We need to increase the amount of biomass that we keep for our soils, and there's a lot of competition on biomass, isn't it? So we need the biomass as food, as feed, for fiber. You could also use the straw as renewable energy source. More biomass leads to more carbon, so it's all converting into soil organic matter. But is it really always carbon sequestration?
I mean, carbon sequestration, isn't it just to get more carbon from the atmosphere into the soil?
That's the point. I found this definition. So carbon sequestration is a long-term removal of CO2 from the atmosphere that is stored somewhere in the soil. And there's the problem, is it? So we have lots of soils, agricultural soils in Europe that loses carbon. And with additional biomass input, we may hamper or dampen this loss, but we won't change it from a source to a sink. Carbon sequestration is only if we get additional carbon stored in the soil. We should be really careful about this.
So how much more carbon do you think we could store additionally in European soils? Is there any data on this?
And that's exactly the question we want to answer with the CarboSeq project. There are lots of data around, but we want to really estimate the carbon sequestration potential that is practically, economically, and technically possible, and not only theoretically. So this is something new, and we want to combine it really with agriculture measures to give politicians an advice where carbon sequestration need to start.
And will you also take into account the socio-economic boundaries?
That's a bit beyond the project. I mean, it's already a huge task. It's 27 partners in Europe from 23 different countries participating here. It's the largest EJP soil project. And if I look at all the administrative burdens and obstacles, I'm really happy that you're part of the project coordination team because it's a huge effort.
Yes, the coordination indeed, it is quite a nightmare. Um, but yeah, let's not talk about this. Let's get back to the topic. So we were at we need more biomass, and where should this biomass come from?
Yeah, there are different agriculture management options. We should also talk about agroforestry or grasslands, but we should also consider the carbon quality, so the biomass quality. There's a huge difference between the carbon that enters the soil below ground with root carbon, root exudates, root litter, or the above ground carbon like the straw and other crop residues. So the roots are 2 to 3 times more effective in building up soil carbon than the above ground biomass. We should talk more about the roots because the roots are the key to sequester more carbon in soils.
I see. So it is not just the quantity, it's also the quality. So to have more stable carbon, so to say. For example, a few years ago, a try to make more stable carbon was biochar and pyrolysis. Um, are these topics you will handle in CarboSeq as well?
Yes, there are work packages on this, and I'm quite convinced that we will talk more about biochar in the future because this is really an option where we can decrease the turnover of the carbon and to convert it into a very stable form. So if we use pyrolysis, the carbon can stay there for hundreds of years in the soil and hopefully also help to make soils more healthy and more productive. For me, it's a key issue. It's not only about putting more carbon into the soil, but we want to make soils more resilient and more productive and more healthy. And more carbon is the key.
But these are all things that are happening on the top of the soil or in the top 30 centimeters. How about the subsoils?
Yeah, the subsoil is an important question because we don't know much about this and we really need more science on subsoils because the carbon turnover as we see it now is slowed down in the subsoil and we could sequester carbon input more efficiently in the subsoil compared to the topsoil. I mean, the question in the end is how do we get the carbon into the subsoil? And also the mechanisms behind it. So why is carbon more stable in the subsoil are not completely clear. We are still having different answers on this question.
So we talked about cover crops, so basically management options leading to more biomass. So we wanted to increase the C input to soil. The next topic we talked about was making this carbon more stable, for example, in the form of biochar and bringing it to the soil. And we talked about the importance or the processes of the subsoil and its importance for carbon. Is CarboSeq really able to answer these questions?
Yeah, I mean, the reviewers of our proposal considered the proposal as partly over-ambitious. It's not only these questions, but even more that we want to tackle in CarboSec and want to answer. The good thing is we have a great team, so many really good partners in all different kinds of European countries, and I'm really happy that we have this joint effort. And I'm pretty confident that all together we will be able to answer many of these questions and really make a significant step forward. But in fact, we should really not only talk about carbon storage in soils. Soil organic matter is the key for soil health and soil productivity, and all the soil biodiversity, all the life in soil depend on soil organic matter. So we should also consider other aspects than only to sequester carbon to mitigate climate change.
Thank you very much, Axel. So there you have it. This was Axel Don, the leader of the CarboSec project within the EJP Soil Framework.
Together with Felix Seidel, the project coordinator.
Thank you for joining us today on our couch and coffee talk, and now please go back to work.